Looking at the night sky is something that all of us do, no matter who we are or where we are. We're lucky here in Australia because we have a great view of the universe. You need to be in the southern hemisphere to be able to clearly see into the centre of our own home galaxy, the Milky Way. As telescopes have got bigger and better, we have been able to look at a lot more of the universe. And of course, we also have many more questions. How do we know where we are located in the Milky Way? How do we know where the Milky Way is in the universe? How far away are other stars and galaxies? What is the universe like around us? What's it like as we go further into space? And indeed, what was the universe like way back at the beginning, at the Big Bang? The thing is, we don't know the answers to many of these questions. But we have developed techniques that help us answer some of them. One of these techniques is measuring redshift. Redshift is a measurement that tells an astronomer how fast something is moving away from us. And it has led to some important discoveries about the universe. To understand redshift, let's go back to basic science concepts. We've all heard the Doppler effect when a motorcycle races past us, engine roaring. The Doppler effect is the change in frequency and wavelength of a wave that occurs when its source moves towards you, compared to when it's moving away from you. As the bike moves towards you, the wave fronts are closer together, resulting in a higher pitch. As the bike moves away, the wave fronts spread out and the pitch is lowered. Let's apply the same thinking to electromagnetic radiation, or light. Like sound, light is made of waves. As a light source travels towards you, the wavelength is shortened because the waves appear closer together. This is called blue shift. Blue light has a shorter wavelength and higher frequency than red light. As the light source moves away from you, the wavelength appears to increase. This is called redshift, as the light is shifted towards the red end of the spectrum. So how can these changes in wavelength be used in astronomy? All atoms emit and absorb electromagnetic radiation in a specific pattern. The black lines on this spectrum are the pattern for hydrogen, the most common element in the universe. This is the hydrogen pattern for the Sun. When we compare the light from distant stars to this pattern from the Sun, we see the same hydrogen lines, but they are shifted down the spectrum towards the red end. They have been redshifted. In the 1920s, Edwin Hubble and other astronomers first started measuring the spectra from objects far away from Earth. The objects were found to be huge clusters of stars, now known as galaxies. Hubble's measurements showed that much of the light received from galaxies was redshifted. He came to realize that the light was redshifted because the galaxies were moving away relative to the Earth. The amount of shift in the wavelength can be used to calculate how fast a galaxy is traveling away from us. This is known as the recessional velocity of the galaxy. Hubble discovered that almost every galaxy was moving away from the Earth. The best explanation for this pattern was that the universe is expanding. Hubble's discovery later led astronomers to the Big Bang as the theory for the beginning of the universe. The Doppler shift of light is used to understand the movement of objects inside our galaxy. By measuring the shifts in the spectra of stars within the Milky Way, astronomers can figure out how our galaxy is put together and how it rotates. Astronomers also use redshift and blue shift to find planets outside our solar system. These are called extrasolar planets. The gravity of a planet in orbit around a star causes the star itself to move slightly. These movements can be picked up in the spectrum of the star as a shift in the lines, either redshift or blueshift.
The Doppler effect tells us how things are moving around us, which is an important step on the way to understanding how the universe works.